Welcome to Study Loop.
Okay, so let's figure out the first question first. Determine the wavelength and frequency of H alpha line. Okay, so what we know here is the grating with 5,000 lines per centimeter. So it's a film 0.5 meter from the grating record space. So we know L is equal to 0.5 meter. Okay, and the 1 over D, which is 1 over separation of double slit, is equal to 5,000 lines per centimeter, which is 5,000 centimeter to the power of -1. Because the lines here is actually not the units, it's just quantity descriptions. So we can just leave the unit like that because the centimeter is the only one that matters. So 1 over D will turn into 5 times 10 to the power of 5 meter to the power of -1 because 10 because 1 centimeter is 10 to the -2 meter. And if you do some calculations based on this conversion here, you get something like this. And we know the formula for spatial separation, and also the spatial separation is given, which is, let's say y1 is, let's take a look, 17.4, okay, 17.4 centimeters. So we know that the formula y1 is equal to m lambda L divided by D. And let's make it look prettier. It will look something like this. And we got 1 over D here and 1 over D here. Okay. M is 1, so we'll get y1 equal to lambda L times 1 over D. So let's do the calculation on the next pages. So we need to figure out lambda first. So lambda will be equal to y1d, okay, divided by L, which is, well, y1 is 17.4 centimeters, so 1.74 times 10 to the -1 meter. Oh, meter times D, which is, if you guys want to calculate it, you guys can calculate it. And I got a value for D from 1 over D, which is times 2 times 10 to the -6 meter divided by L, which is 0.5 meter. And that will give us, let's say lambda 1, okay, equal to 6.96 times 10 to the -7 meter, which is 696 nanometers. Okay, and let's use another page. The frequency. We know the frequency is equal to 1 over t, and t is equal to lambda, which is the wavelength, divided by the speed of light, which is c. Because wavelengths basically consider like a distant type quantity, and it's just speed of light c here. So it's distance divided by speed, which is equal to time of the period. So, yep. So f, since it's a reciprocal of the t, which is just equal to c divided by lambda, and f for this case, F1 is equal to C. We know the speed of light is 3.0 times 10 to the power of 8 meter per second divided by 6.96 times 10 to the negative 7 meter, and that should give us something like, let's see, it's pretty big. Let's see, it's 4.3 times 10 to the power of 14 hertz. And that's the solution for the question 1. And let's take a look at the question B. Let me make sure, let me mark it real quick. So, A, okay. Question B, here we go. It's the same type of question. It's still trying to determine the wavelength and frequency. Just the data was given different. So in this case, the separation Y2 is 18.4 centimeters, and L is still the same. It's 0.5 meter. D is the same. 1 over D is 5 times 10 to the negative 5. Oh, sorry. It's 10 to the 5. Meter to the power of negative 1. And we know Y2 is equal to M lambda L over D. M is still equal to 1 because we're still talking about the first order. So just lambda L times 1 over D. And it will give us lambda 2 for this case is simply equal to Y2D divided by L, which is 1.84 times 10 to the negative 1 meter, because 1 centimeter is 10 to the negative 2 meter. And then times D, where I get it before, which is 2 times 10 to the power of negative 6 meter. And then divide by L, 0.5 meter. And we'll get, let's use a calculator real quick. 7.36 times 10 to the negative 7 meter, or 736 nanometer, since 1 nanometer is equal to 10 to the negative 9 meter. And let's figure out frequency for this case. So, F2 is equal to C over lambda 2, which give us 3 times 10 to the power of 8 meter per second divided by 7.36 times 10 to the negative 7 meter, and that will give us, let's see, 4.08 times 10 to the power of 14 hertz. Okay, and that's the answer for question B. And let's take a look at question C. Well, for C, I'll give us some directions. Okay. The one possible reason why there's a difference of frequency between H alpha from the lab source and H alpha line from the galaxy is because the Doppler shift. Okay, it's because the change in frequency of the H alpha line from the lab source and the H alpha line from the galaxy is that the line is a Doppler shift as the galaxy hydra is receding from us. And I mean, yeah, it might sound kind of complicated, but if you really want to just make it simple, just say the possible reason why there's a difference between the frequency, you can just say it's due to the Doppler shift. So, you know what, I'll just write it down. Just say it's due to the Doppler shift. Okay. There's no S here, sorry. Okay. And thank you. And that's all the answers for the such questions.